Thanks, Terrell. We're happy to be here and to present the Alexander, which is a project, really fantastic one that Leonard approached my firm with, looking to design a passive house seniors facility, which, had we gone the certification route, would have been the first in the country. But we went the performance route, and we're going to talk about that today. So we're not going to talk about the whole construction and everything like that, but we're just going to run through quickly. We have a little short video. I'll give you some stats on the building. And then Leonard's going to jump in with some benefits of passive principles from an owner's perspective. And then John's going to jump in from a builder's perspective of lessons learned, challenges, etc. This is the Alexander Muskoka residence. It's a 75,000 square foot retirement facility, a continuum-of-care model, which has independent living, assisted living, and then memory care facilities. It's a Class C retirement home. It's 3 stories, fully sprinklered. This will be important down the road. You'll see when we talk about code issues. A main dining room, as you can see here. 2 auxiliary dining rooms for certain care models. The memory care wing has its own dining area and things like that. As you can see, this is one of those service carts that they'll take over to the auxiliary dining rooms. There's a central commercial kitchen. Main common areas include an atrium space, the dining room. This is a board/auxiliary dining room. This is the atrium space. There's a bistro, laundry, lounges, library, a lot of the kind of standard facilities you'll find in a retirement community. There are 100 suites in this. There's a mixture of 2-bedroom, 1-bedroom, and studio apartments. It's 30% are barrier-free units, as defined by code. But all the units are actually designed so that they could be retrofitted to be barrier-free. You'll see there's a shot here. There's no thresholds throughout the entire building. So there we go. So from the bathroom to the bedroom, from the upper lounge to the terrace on the 3rd floor, there's 0 threshold. Really thinking about, obviously, the occupancy. There's really wide hallways. I think in some areas they're 7 feet wide, obviously for mobility of people passing and things like that in this kind of occupancy. And every suite has individual control over its temperature and its ventilation. As you saw, the windows in the suites are rather large per suite. I think they're total of, 7 feet wide by 6 by 8 maybe. Anyways, they're tall, and one's operable and one's not. So that's the Alexander. Yay! If you just want to flick through the next slides there, Daryl, and then we'll let Leonard take over here. There we go.
Okay, owner opinions. I guess from my perspective here, any of you in here got a significant other? And you know how hard it is to kind of get on the same page with temperature. Now, we've got 100 suites here. Right now, we've been open for less than a year and a half. We've got 85 residents. We've got 50 plus employees. And we have a lot of service providers who enter this building all the time. So comfort criteria was a very important thing for me. I knew nothing about building efficiently or sustainability. I'm a nurse by profession. But I always thought that what would be best for the end user and what would be best for our environment. And then I started doing some homework and some researching, and I came across passive house and passive house standards. I didn't know anything about it, but I just thought when I looked at it, it had very simple methodologies like more insulation, thicker walls, deal with penetrations. It was something that I could wrap my head around. And so then I kind of looked into where I could find somebody to help me kind of build this, and came across Craig and Greystone, and the rest is history. Next slide. I think what's happening here, if you think about when you're a baby, you have very poor kind of thermal regulation. The same thing happens as you get older. So if you've ever walked into your grandmother's house or an older person, you're like, why are they trying to cook themselves? It's super, super hot, right? So that's kind of what we're trying to achieve, that where we can achieve some sort of satisfaction amongst a lot of different people. So hence our endeavor to go down and build a passive house to create that sort of consistency in climate, no drafts, and just a nice comfortable area for folks to use. Next slide. And I think just from anybody in here who's a developer and looking to do, whether it's a seniors resident or whether it's a condo, an apartment, I truly do believe that it does support kind of your business operation. So for example, in a retirement home, we just burn through money until we get to about 60-65% occupancy. It's millions of dollars. So the best way that you can help some of that is through your op costs, lowering your usage costs. But then also I do firmly believe, even this generation, they do care about the environment. And I think the next generations will care about the environment, the comfort criteria, and building just a better product. So that's kind of where my insights as an owner came, where this made sense for me. Just, I started learning more. Let's try to do better if you know better. And that's where we ended up. And I think when you know better, all of us should really try to do our part in contributing to the communities and societies that you live and you play in. So that was kind of one of the criteria and goals for us when we set out to build this building. Next slide.
Thanks, Leonard. So when we first got involved in this project, I have to admit that passive building and passive design wasn't really something that we did often. But one thing we do like to do at Greystone is learn more about building better. And these principles are something that through this project with Leonard and with Craig, we learned a lot about. And initially, this project was designed with CLT floors, a double exterior wall system. It was incredibly well insulated, incredibly well designed, just an unbelievable building. But what happened was through the tendering process, it was very high cost and didn't work for Leonard's business model. So at the end of the day, he had to, called me after that and said, what do we do now? We can't make this thing work. This thing won't get off the ground if we don't find some savings. And that's where we got to work. So at the time though, the passive house standards and passive house performance was still a very important criteria for Leonard. So we had the challenge between Craig, our company, and Leonard to find something that worked and checked as many boxes as possible. So maybe it wasn't going to get full certification. How close would we get? How close could we get to that and still meet a lot of the criteria, still provide a very high-performing building? Energy modeling was heavily used on this thing to try to figure out what decisions to make along the way, and mainly with insulation values. At the time, we hadn't used the R30 ICF product before. We used R22 a lot. But again, performing energy modeling provided a lot of savings from an energy use perspective. We played around with code requirements and upgrading from there. So I think code requirements at the time were R5 under slab insulation. We put R10 in the model, and there was a massive improvement in building energy usage and performance. We went to R20 just to see what that would do, and the relative improvement from R10 was very small. So that's how we made decisions throughout, is really heavily relying on the energy modeling that Craig did. Same with flat roof insulation, windows. We ended up with triple glazed windows throughout. We did hollow core precast throughout, and basically designed the floor plan to work with typical spans. Again, if we were using a CLT system, I would have done the same thing, working with typical spans to keep costs down. Just at the time, this was mid-COVID, and wood wasn't the best price in the world at that point. That was sort of $100 a sheet plywood days. So at the time, to make this thing work, that's the direction we went. Lots of advantages to going with concrete, of course. We already talked about that, drywall, fire ratings, all that stuff. In the end of the day, we were able to pull about $10 million out of the cost of this thing. It came in around $30 million in the original tender. Now, Leonard doesn't want to hear this, but could we have made it cheaper? Absolutely, absolutely. But we didn't, because we still were trying to do what we could to get as close as we could to what Craig was modeling for us to reach these passive house sort of standards.
I just want to jump in
Go
quickly
ahead,
on that number. So when we did the original value engineering, Greystone, what they did was they took the exact same design and just went from combustible construction to non-combustible construction. And it dropped 7 of that 10 million in savings. And then the remaining 3 was some design alterations that we did. So I'll touch upon that in a couple minutes here.
Yeah, and so, I mean, it was a good example of a situation where we had a team that was willing to work together to achieve a goal. I mean, if at that time, I mean, the question was, Craig, will you work with us to figure this out and make this thing real? And as much as that passive house design that was really groundbreaking and would have been, nothing like it in Canada, it wasn't buildable. It wasn't possible. And so we'd rather see a building come to life that's super efficient and works and can be a sustainable business plan as well as a sustainable design, and still has very low energy use. And so that's sort of the story from our perspective on this. I can go next slide. So moving forward, energy modeling. So we've done a number of projects, obviously, since this one. We are almost always using energy modeling to rely upon for figuring out the best design above code for most of our buildings when energy efficiency is a priority. We do public sector projects, and I'm seeing right now in their RFPs, they're very, very strongly prioritizing energy efficiency, and they're now asking for energy modeling to be included with our proposals. So this is now becoming standard. 5 years ago, it was not. So learning approaches, products that work well together for both capital cost and long-term performance. So this is just an ongoing learning thing. So, everything we built the Alexander Muskoka residence out of doesn't mean that that's going to make the most sense in 2 years, 5 years, 10 years. I think the industry is evolving, and there are products that are becoming more cost-effective to use as the industry gets used to them, as cost of labor changes, and we do more off-site construction. We're doing more off-site construction than we ever have before, and that's going to continue. So this design could be different in the exact same spot, in another 5 years, even 2 years, even today. Ongoing evolution, again, must continue to evaluate all options as the industry changes, and that's what we continue to do today on new retirement homes that we're looking at and other similar buildings. So constructability and performance, I just wanted to provide a quick bullet list of sort of the things we talked about before the construction started, during construction, and even after. The way we built this, the way we designed it, we did end up with an extremely efficient schedule with minimal weather impact. So everybody's familiar with working in Muskoka in the winter. The systems we used here allowed us to just keep trucking right through without stopping. Competition, that was related to my earlier comment about COVID. In the marketplace, when you're looking at different products to use to put a building together, depending on what's happening with viruses that are traveling the world or presidents that are making random decisions on a week-to-week basis, you might have to make different decisions when at the end of the day, there's a business that needs to pay for a likely substantial mortgage for a number of years. So if that equation doesn't work, the building doesn't happen. And this is coming from a sector where most of our clients, if not all, are business owners. So this becomes a pretty important thing for us to evaluate. Construction details, that was a huge topic during construction. You can pick all the products you want and put it in the modeling, but if you don't build it right, it's not going to perform. we identified very early that the weakest part of our ICF building for Leonard was every single penetration. If we didn't deal with that properly, then there was no point in doing all of the modeling and everything we did. So that was something we focused on during construction, and Craig was out talking to us about how we were doing, especially our exterior penetrations, and we talked about details around that. And we continue to talk about it to this day. There's new products coming out to help us with that all the time. Embodied carbon, big topic on this one. Again, we would never have otherwise talked about embodied carbon on this project if not for pushing these standards and for Craig's knowledge on it. So we ended up talking to our concrete suppliers and asked, what are they working on? What can you do? They had mixed designs that had lowered their embodied carbon. They're working on this actively. Concrete might not be the perfect product for Passive House, but it's sometimes a necessary product. And so across the industry, what we're seeing is every supplier working on this stuff and getting better. So that actually was a major topic during this project that we, obviously using so much concrete was pretty important. Life cycle costs, obviously, running this building, running this operation, it's I don't know, it's massive, 75,000 square feet over 3 floors. A lot of heating costs, a lot of cooling costs, and maintenance costs. So even product selection in terms of exterior finishes was important, and all of that was incorporated into the design and construction. I already mentioned the business case, I don't need to go over it again, but that was one of the driving factors behind the decisions we made on this and as a team and move forward with.
Okay, here, I'll run through this quick because I think we got like 2 minutes. Yep, there's the 2-minute marker. Okay, let's address the obvious. Embodied carbon, elephant in the room. As John already alluded to, there was a lot of decision making. We can switch to the next slide. So really what it comes down to, one of the major differences, because of the scale of the building and the occupancy, the use of the building, when we are in a combustible region under the building code, we require a 2-hour fire rating. So that means every single suite door, because it's a supporting wall, now becomes a 1.5-hour fire separation, which is very expensive compared to a 3/4-hour fire separation when we move to non-combustible, when the fire rating only needs to be an hour. These are our original R values and sound transmission class. This is what we ended up with. And if you go to the next slide, you'll see the energy performance. So I work with all my clients. We go back after the building's been in use for at least a year to evaluate actual energy use versus what we've modeled in the PHPP to see how results are, to see how we can improve our modeling for the next round. So the initial PHPP, we were at 124 kilowatt hours per meter squared for our primary energy use, which is 4 kilowatt hours over what Passive House is. So, we're even with those changes, we're really close. Our actual energy use came in at 134. And if you click, energy modeling variance is usually about plus or minus 20% is considered a good result. Click again. Our actual energy use is 9% higher than modeled. So what's going on? We can rotate. Where's the difference? As Leonard said, this occupancy type, they like to keep their rooms warm. So when all the rooms are at 24 to 29 degrees Celsius, the Passive House modeling, we model at 20 degrees Celsius, right? So obviously we're not going to get the same result. But when we switch to 24, we start to get really close to what we're seeing in real life here. So if you want to click through, the residents are heating their rooms on average, higher than the modeling. Sometimes there's a tendency to leave televisions running all day long.
Everything is on.
Everything's on. Commercial kitchens are typically underestimated. We use energy modeling guidelines, but chefs in particular turn on
they cook
burners
nothing.
And
the
they just leave
gas is on just all day long.
They leave them on all day long. So they just switch pans around, right? And then there's some additional plug loads that we didn't pick up originally for the nurse call system that was specified. It was a bit different than what we
bringing
had originally,
that every minute,
etc. In comparison to the sector, the EUI of seniors living facilities in Canada in general nationwide is 1.5 gigajoules per meter squared. The Alexander is, bam, 0.4. All right. which means we are in the top 2% of energy use nationwide for seniors facilities. So passive principles do work. Oh, and we have some occupant comfort criteria. We can just skip through this quickly since I know my time's up. But we got check marks all across the board. We went and we talked to the residents to see if everyone's comfortable, very happy with the building. Don't notice any temperature differentials between windows and stuff, so worked out.